Okay, so question 5. An investor has finally decided to invest in the stock market. It comes to you seeking your expertise in this field. You recommend that he invest part of his savings into stocks A and B that you have been following closely for some time. The portfolio will not be well diversified, but nonetheless, you believe that both assets will do well over the course of the next year. Here are your estimates concerning two equities. So I've copied those down. You recommend the following portfolio: 70% A, 70% B. This portfolio is the least risky portfolio among all the ones you can construct if we constrain ourselves to only A and B. So whenever we see least risky, we're talking about minimum variance. So compute expected return and standard deviation. So the expected return part is very straightforward. So we go 70% times return A plus 30%. So weight of B times return B. This gives us 13.8% portfolio return. For the standard deviation, it gets a little bit more complicated because we're missing some information. So to be able to calculate standard deviation or variance, we need to have to know either the correlation term or the covariance term. So we need to calculate this. We're told that this is the weights we're given, 70 and 30, are the weights of the least risky or the minimum variance portfolios. We can use the minimum variance formula to deduct the covariance terms. The minimum variance formula is this sigma b squared minus the covariance between A and B over sigma A squared plus sigma B squared minus 2 times the covariance term. So we have this, and the weight of A as calculated is 70%. So the only thing we have to do is just some simple arithmetic to solve for the covariance term. So I'm not going to do it. It's not too long, but it's probably pretty boring to watch me solve this. But this gives you a value. If you do it right, it will give you a value of 0.25%. So using this is the covariance between A and B. So using this, we can now calculate the variance of the portfolio. So recall the variance is the weight of A squared, sigma A squared plus weight of B squared times sigma B squared plus 2 weight A weight B covariance between A and B. So this would be your 0.25%, and now you can just replace all of the other values in the formula, and this should give you a variance of 2.875%. To calculate standard deviation, we just take the square root of the variance, and this gives us a value, a standard deviation of 16.96%. Now for B. Okay, so for B, the investor believes that the above portfolio is too risky. You propose to allocate part of this wealth among a risk-free asset in a portfolio composed of stocks A and B. The yield on treasury bonds for the investment period is 6%, so the risk-free rate is 6%. You estimate the level of risk aversion of the investor at 4, A equals 4. What allocation will you recommend to the investor? So the first step here is to find the weights of the tangency portfolio and not those of the minimum variance portfolio that were given to us previously. So look at your formula sheet, find the tangency weight formula, just replace the numbers using the value of the covariance term that we found previously. And this should give you, to save us some time, I'm going to skip the calculation, but this give us a value, a weight of A of 52.3% and a weight of B of 47.7%. Now that we have these are the weights of the tangency portfolio. So now that we have this, we can calculate the expected return and the standard deviation of the tangency portfolio. So doing this, we found expected return of the tangency portfolio is 14.9%, and the standard deviation of the tangency portfolio is 18.1%. Now the question is, what allocation will you recommend to the investor? So the final step, so we can now determine the optimal allocation between the risk-free asset and the tangency portfolio. So that's our Y star. This is given by this formula, okay, sigma squared P. So basically just replace those values with those we find previously. 4 times 0.1% squared. This gives us a Y star of 67.8%. Now that's not exactly what we're asked. We're asked what the optimal allocation will we recommend. So the final allocation will therefore be, let's say 1 minus star, so 1 minus 67.8%. That's 32.2% in the, let's say, risk-free asset. Then we'll invest sigma star times weight of A, so that's 67.8% times 52.3%, and this is equal to 35.5% in A. And similarly, sigma star times weight B, that gives us 32.3% in asset B. And that's the answer we're looking for.